Hi, I'm Dalbir Singh, and today I'd like to share with you all the translate function in SQL Server and why you may wish to use it instead of nested replace statements. So to begin with, let's look at an example in SQL Management Studio. So here I have a varchar variable that holds a flight number. In this case, that's Ryanair 7 Alpha Whiskey. And what we want to do is sanitize this string and remove the brackets and the hyphen so that we end up with a clean output as highlighted here. Now, one of the ways that you would achieve this is to use nested replace statements, and the output would look something like this. So as you can see, here's our unsanitized string, which is the flight number with the brackets and hyphen, and here we have a clean output without the brackets and hyphen. Now this is fine, but if you notice, we've had to use multiple nested replace statements, which affects readability of our code. So is there a more simple way that we can make this more readable and write less code? Well, it turns out there is. We can use the translate function. Now, something to be aware of with translate is that it's relatively new. It's been available since SQL Server 2017 and is also available on the Azure SQL database. As you can see from its definition, it has a very similar parameter construction to replace statement. So what I want to show you here is the characters parameters and the translations parameters and how they actually work. And this is where translate is different to the replace function. To start with, all the characters that are entered are seeked on an individual basis. So indexing and ordering matters a lot in characters and the translation parameters. To give you an example, I've got capital A, B and C as my seek characters, and these all have an ordered position that they're sitting in. I've got 1, 2 and 3. What will happen is if a capital A is found within the input string, then the replacement character will be looked up from the translations parameter collection, and it will pick whichever character is in the same index as the character that the match was found for. So as an example, if a capital A was discovered, since it sits at position 1, whichever character is on position 1 in the translations parameter is the character that will substitute for the capital A. And the same will happen for, let's say, capital B. Whatever is sitting in position 2, since capital B is in index 2, will replace capital B, and then the same for C. Now, something to be aware of is that because of how this works on indexing, you must make sure that both parameters have an equal amount of characters. If they do not, SQL Server will throw an error. So using the above, let's look at an illustrative example. Here you can see I've got the text string Alpha Bravo Charlie, and the characters that I'm seeking for are capital A, capital B and capital C. And then here are the translations or substitution characters. So capital A we know will be replaced with a lowercase a, capital B with a lowercase b, and capital C with a lowercase c, which means the output then becomes Alpha Bravo Charlie with the first letters of each word now lowercase. So let's see how we can implement this in our original scenario in SQL Management Studio. So I'll begin by adding it as a separate column. So translate. Let's put in our input string, which was flight number. Now we're going to declare the characters array. So these are all the characters that we want to search for and replace. So we don't want the brackets, if you remember, and we don't want the hyphen. So we're going to search for all of these characters. And now we need to define the replacement. And this is where things get a little bit tricky, because if you remember what I said earlier, you must have an equal amount of characters to search and the characters to replace. Now in this instance, I actually just want to remove these characters. So I don't want to replace them with anything. But with translate, I can't do that. And if you were to try and put in white space, all you would achieve is just putting white space replaced for every character that was matched. So what I'm going to do is a two-stage process. I'm going to firstly identify a token that I know will not appear in the string. In this case, I'm going to go with the hash sign. And I'm going to replace every character with the hash sign. So every character that's matched with a hash sign, okay? And let me just close that. Now let me just show you what this looks like. So let's alias this as well. So flight number, and we'll call this one translate. Okay, so you can see here we're not quite there, but we've managed to change all of the characters that we don't want into a token. In this case, my token is a hash. So what I can do here is I could actually put in an outer replace, and I could say for that entire string, locate the hash and replace it with nothing. Okay, it's where IntelliSense gets a bit screwy. There we go. Okay, let's try that. And as you can see, I achieve the exact same result now. And it's a personal opinion, but to me that's much more readable. Yes, there is one layer of nesting that's necessary for our example, but you can see here I've been able to identify all the characters that I don't want just in one function call, and essentially replace them with the same token and then a final outer replace to just get rid of that token. And you can achieve the same result, but I find that a lot more readable, and so I hope you find that useful. So thanks for watching, and if you enjoyed the content, please don't forget to like and subscribe. Thank you.